Hey, welcome! Today we're going to tackle a word I guarantee you've heard 1,000 times. Monsoons. But, I'm willing to bet that what most of us think a monsoon is and what it actually is, well, they're two pretty different things. So yeah, let's get right into it.
So let me ask you, when you hear that word monsoon, what's the first thing that pops into your head? For most people, it's probably just a crazy downpour, right? A huge, relentless rainstorm, or maybe even the whole rainy season. And that makes sense, but it's not quite the whole story.
Because here's the real scientific definition. A monsoon isn't actually the rain itself. It's a massive, seasonal wind system that literally reverses its direction twice a year. The rain, that's just the consequence. It's a super dramatic effect for sure, but the wind is the cause. And that simple idea, that flip, is the key to this entire global phenomenon.
Okay, so here's our game plan. We're going to really lock in what a monsoon is. Then we'll look at the most powerful example on the planet, Asia's great wind reversal. We'll tell a tale of two very different seasons. Then we're going to hop over to North America to see it in action there. And finally, we'll dig into why these incredible climate engines matter so much to all of us.
All right, let's start with that big idea. To really get monsoons, you got to force yourself to stop thinking about the rain for a second and start thinking about the wind. A huge, predictable, seasonal flip-flop of the wind.
And what's so cool is how simple it is at its core. In the winter, you've got this steady wind blowing from the land out to the sea. That's your winter monsoon, and it's usually super dry. But then, summer rolls around, and the whole system just flips 180 degrees. The wind reverses, blowing from the sea onto the land. And that's the summer monsoon, dragging all that ocean moisture with it, which is what gives us that famous rainy season.
And there is absolutely no better place to see this in action than in Asia. I mean, this is the big one. It's home to the most powerful, most intense monsoon system on the entire planet. It affects billions of people.
So what in the world drives something that massive? Well, it's actually a super basic principle of physics that you already know: unequal heating. The huge Asian continent heats up and cools down way, way faster than the gigantic oceans around it. This difference in temperature creates a massive difference in air pressure, and that's the engine.
Let's walk through it, starting with winter. So picture Siberia. The nights are long, the sun is low, and just frigid air starts to pile up over that enormous landscape. All that cold, dense air creates this powerful high-pressure system. We call it the Siberian high. And just like air rushing out of a balloon, this cold, dry air flows outward, away from that high pressure, sweeping right across Asia from the land out to the ocean. But then, summer arrives, and it doesn't just tweak things, it completely flips the script. That cold, dry breath of winter is about to get replaced by a warm, wet inhale from the sea.
So now what's happening? Well, the intense summer sun is just baking the inside of the continent, right? Temperatures can get over 100 degrees Fahrenheit. All that hot air rises, and it creates this huge area of low pressure over the land. And nature hates a vacuum. So to fill that low pressure spot, all this moist, heavy air from the cooler oceans gets sucked inland. And that's your summer monsoon.
And just how much moisture are we talking about here? It's just incredible. In one place in India, Cherrapunji, they once recorded 25 meters, that's about 82 feet of rain in a single year. To picture that, that's like an 8-story building's worth of rain, and almost all of it came down during just those few months of the summer monsoon. It's just wild.
So let's just put it all together real quick. In winter, you've got the Siberian high over the land pushing dry winds offshore, which means a super dry season. Then in summer, you get a thermal low over that same land which pulls moist winds onshore, creating that massive rainy season. It's a perfect dramatic reversal.
Now there's another global player that kind of juices this whole effect. It's called the Intertropical Convergence Zone, or the ITCZ. The easiest way to think of it is just as a belt of rain that wraps around the globe near the equator. As the seasons change, this belt follows the sun. So in the northern summer, it moves north over Asia, which just reinforces and strengthens that rainy summer monsoon even more.
But here's the thing. This isn't just an Asian story. A similar thing, just kind of on a smaller scale, happens right here in North America. It's a different flavor, for sure, but it's driven by the exact same idea.
So, the North American monsoon hits the southwestern U.S. and northwestern Mexico, and the pattern is classic. A really dry spring, followed by a much rainier summer. You see it most clearly in states like Arizona and New Mexico, even though the whole system is actually at its strongest down in northwestern Mexico.
And this chart really tells the story perfectly. Just look at the rainfall for Tucson, Arizona. In May, at the end of that dry spring, you get almost nothing. But then look at August, right in the peak of the monsoon. The city can get nearly 10 times more rain. It's a total transformation of the desert.
And how does it work? Well, it should sound pretty familiar by now. It's the same mechanism we saw in Asia, just shrunk down a bit. That intense summer heat bakes the desert, creates a thermal low over Arizona, and that low pressure pulls in moisture from the Gulf of California and the Gulf of Mexico. Boom, you get those famous summer thunderstorms.
So, we've got the science down, but so what? Why does this all matter so much? Well, because this isn't just a quirky weather pattern. It's a global climate engine that is deeply, deeply tied to human survival.
Just try to wrap your head around this fact. Nearly half of the entire world's population lives in areas directly affected by the Asian monsoons. We're talking about billions of people whose lives, their economies, their cultures are all shaped by this seasonal flip of the wind.
And this quote from our sources, man, it just says it all. For billions of people who rely on farming to survive, the timely arrival of monsoon rains often means the difference between adequate nutrition and widespread malnutrition. It is no exaggeration to say that for huge parts of the world, the rhythm of the monsoon is the rhythm of life itself.
So look, if you take only one thing away from this whole explainer, let it be this. A monsoon isn't the rain. The rain is the effect. The monsoon is the cause. It's that powerful seasonal reversal of the wind that brings the life-giving rain.
And that leaves us with a pretty important question to chew on. These massive seasonal shifts, they're a fundamental rhythm of our planet. We've just seen how billions of people depend on that rhythm being predictable. So, as our global temperatures continue to change, you have to ask, how might this ancient, powerful rhythm be disrupted? That's definitely something worth thinking about. Thanks for watching.